Hello, James Black here with your video for the Linear Variable Differential Transformer Laboratory of Measurements and Instrumentation. It's fall 2019 at Montana State University. This is the schematic that's the basis of our equipment setup. So note we have, down here we have our LVDT, and we have these four terminals, yellow, green, red, and black. That's what the Y, G, R, and B stand for. So for the yellow and green, that would be the primary coil. We're bringing in from our function generator sinusoidal wave, an alternating current. We're going to split that and run one branch of that to our oscilloscope. That's going to be our reference so we can get the direction information. The other branch of that we're going to use to power the primary coil to produce that magnetic field. The output is going to come from the red and the black terminals, and we're going to connect those to a resistor. We're going to have a couple different loads on that resistor through the lab, and then the voltage drop across that is what we're sending to the oscilloscope. I've wired that up. So here we have our function generator, and out of the main output, I recommend that you try to make your wiring as simple as possible. So I made this little coax splitter in the middle. I have one coax cable that runs over and goes into channel 2 of the oscilloscope. That's this. Then the other branch of that, these are the green and the yellow, and they're coming in here to the primary coil of our LVDT. Then the output of that, that's the red and the black. We're bringing them over here to our decade box. And then the voltage drop across that we're bringing up here into channel 1 of our oscilloscope. So let's fire these up. Here's the oscilloscope, and here is our function generator. Let's look over here, the lab handout. So it says our signal should be 10 kilohertz and anywhere between 1 and 5 volts. So it's running. It looks like it defaults to 10 kilohertz. That's exactly what we need. But the voltage output is 20 volts peak to peak. So let's switch that. So pick amplitude, and then you should be able to press 5 and volts. So again, the max of that acceptable range. That's it. We don't need a DC offset, anything else. Just we see it's a sinusoidal wave. So that's all good. It should be coming down here. We're told to use two different resistances. One is 10 kilo ohms and the other maybe 100 ohms. Check the lab handout. But there you can see we've set that, and we're running it into the oscilloscope. We're going to need to set the oscilloscope up. So exit out of that, and then, oh, I see we don't have a signal coming out yet. You have to press this to actually produce a signal, and there it is. Actually, that's really good right there. You see really nice clean signal. Where the blue one, that's our channel 2. You can see that over here on the left. Yellow is our channel 1. You actually can't ask for much better than that. The handout tells you to set the trigger to channel 2. Since we're sending that input into channel 2 for our reference, that's going to be the higher amplitude, the steady signal, and that is what we want our system to look for, to lock into. If yours isn't set to that automatically, you can press over here on the trigger menu, press this, and we see ours is set to 2. Let's see what happens if we set it to 1. So if we set it to 1, it's still fine. But if I reduce the magnitude of the output too low, it's going to start jumping all over the place. So we are going to have to take readings at this point, and we don't want this. So that's why we switched to 2. Let's switch it back to 2. And there we go. We have a nice steady signal. Actually, we're pretty good at this point. There's not a whole lot else that we need to do other than make the measurements. I don't know that I want to tell you exactly how to do that. There's a measurement button up here. If you press that, you can start cycling through here to find the measurements that you need to complete the requirements of the lab. I'll show you how this works a little. So this is the LVDT. Here we have this apparatus where if we turn this, actually the LVDT is back here. This is just an apparatus to move that core. So as we turn this, the core moves in and out. You can see we're measuring that over here. One thing you're going to want to do is look over here. So right now the core is closer to the secondary coil that's in phase with the primary coil. If we start moving towards the center, the amplitude of that output drops. And at some point, like right in there, you're going to want to make that your null position. When you do that, you can come down here and zero this gauge. There's this little set screw here. You can turn that and set this. You want to zero it out. So now you're going to get, so note here the units are 1/1000th of an inch. So as you spin this, you're going to move that core the corresponding distance, what this gauge shows. Over here, now you see we're moving the opposite direction. So we're getting an output that is out of phase with the input. I will show you this. So measure, measure, cycle through. Where did I miss it? Oh, here we go, phase. So from channel 2 to channel 1, that's what we want. So say OK, we create the measurement. You can turn off this menu to give us a little more space, and there you see the phase angle, and it's pretty close to 180 degrees. That's what we want. Like we said before, there's a little bit of lag between our reference and then the signal that goes through the LVDT, through the resistor and out and in. So we don't see the ideal of 0 and 180. Here we're seeing 177. So we're seeing 3 degrees off from that. If we go in the other direction, just rotating that knob, there so it's jumping around. You'll often see say like a multiple 360 in there, but you often see that -3 popping up. So pick something there that makes sense. The other measurement was more stable. This one's jumping around a little bit more, but you keep seeing that -2, -3, -4, -5, somewhere in there. That's what that phase offset is for the one that's in phase. Well, that should be enough. Good luck with your lab.